In our previous tutorials, we used N8N to collect YouTube metadata, Gemini embeddings to represent the video content, and Neo4j to store the graph. So in these tutorials, we connect the existing knowledge graph to OpenClaw through a customer MCP server. And now let's see what we can do. What videos do we have about Neo4j, N8N, and OpenClaw? And now we can see the return response. So based on our YouTube knowledge graph, and here are the videos talking about OpenClaw, Neo4j, and N8N. So it returns 3 videos. So here we are going to try to ask another question. So based on the current videos, what is the learning path that I should follow to learn those 3 tools? And so here are the returned learning paths. So step 1, step 2, and step 3, and step 4. You can see that with this MCP server, our agent is become smarter and understand our knowledge graph. All right, so this is what we're going to build today. We already have our Neo4j database, and we have our OpenClaw AI agent on the Google Cloud VM. So we also published MCP server for this tutorial. So later, we are going to set up this MCP server in our Cloud VM. And also, when we ask question to our AI agent will call this MCP server. So what is MCP? So MCP is a protocol that standardizes how AI agent connect to external tools, resources, and prompts. We still need to build or configure those tools, such as query Neo4j features. And however, once they are exposed through this MCP server, and AI agent can discover and call them to answer questions based on our existing Neo4j knowledge graph. So this is our graph database. Each green dot represents a video, and they are connected with other nodes based on the same topics. We also can tell that each node also has embedding. So we create fact index based on this video embedding for all the videos. So if you haven't done that, just run it. So we already set up this YouTube GraphRAG MCP server, which essentially is a Python code that allows your AI agent to use those predefined tools to query data from our Neo4j database. So there are multiple MCP servers available, including the official ones from the Neo4j. And this one is just designed specifically for our tutorials. So those are the tools that we defined. And once we set up this MCP server, and OpenClaw will be able to use those tools. All right, so now we're back to VS Code. First, we're going to just copy that MCP repository. So this is a git colon. Again, all the code will be posted on our LP Social website. So we just copy that code. Right now, you can see we have this code that just being downloaded. And if you go to the MCP folder, and this is the server.py file that I just mentioned earlier. So this included all the predefined tools that our AI agent can use. All right, so now let's go inside of this folder. All right, so here we did 2 things actually. So UV -- version, just check the version of the UV that we installed. And then you can just run this UV sync that will install all the required Python packages for this MCP server, and also build a virtual environment for this MCP server. Next, so before we start the MCP server on our VM, we also need to provide the credentials. So here you can see we have this v.example. So here we are going to provide our Neo4j credentials, embedding providers. So by default, we're using Gemini. So feel free to delete OpenAI. And also here you need to provide your Gemini API key. We're using this 768 dimension for the embedding. So that's what we did in the previous tutorial, and we're going to keep using this one. This should be enough for our videos because we have like 4 or 5 videos right now in our database. We also keep using those definitions of our GraphRAG. So let's just rename it. So I'm going to remove the .example, and that will make this one a real env files. And next, so since I'm not going to use OpenAI, so I'm going to remove that. All right, so you can see here, I just copy and pasted my Neo4j credentials. and also my Gemini API key. So now we set up this env files. So let's just run a test of our local MCP server. So here you can see we provided several ways to test these MCP files. Like you can just ask questions, or you can just list the menus and also do a very quick test. I'm going to run this one, Python local tool menu. You can just run that in this environment and also test your MCP and also especially connection with your GraphRAG system. So here you can see now the server is running. We are using the standard IO mode, which means that we are running the server locally on this VM. So here we have those predefined 8 tools. If you want to get the structure of your node and also indexes, you can just type 1. We can see that we have retained like the nodes and also relationships, and also we have index. So let's also try the second tool, that is semantic search. So what is the question? So what do you want to find out from your videos? So I'm going to try N8N. And how many videos or items will be retained? Remember that I only have 4 videos. So the maximum will be 2. So from the 4 videos, I'll just retain 2 videos that talking about N8N. All right, so here we can see those are the return results. The video title, deploying N8N on Google Cloud via Docker. So here we have the descriptions, the topics, the URL of this video. We also have our second written video, that is OpenClaw plus N8N webhook. We also have the descriptions. All right, so let's try another tools. Let's say we're going to find out the most recent videos. So let's type 4. Okay, so how many videos do you want to find? So let's say the most recent one. All right, so that's the most recent one. That is OpenClaw N8N Neo4j. Okay, so looks like the MCP server is working. So now I'm going to click quit. So our next step is that we're going to register this MCP server to our OpenClaw AI agent. So the idea is that without this MCP server, if we ask our AI agent to query the data from our database, the AI agent will have a hard time understanding what we have in the database. And also it can also be very creative to try to figure out different ways to query database and also wasting our tokens. So MCP is more like a protocol. So with MCP server, the AI agent will know that what other predefined tools exist in this MCP server. So when we ask question to our AI agent will choose the right tools in this MCP server. And also the server will send out the query to our database. The database will retain the data that requested and finally send back to our AI agent. All right, so let's try to register these MCP servers. If we run OpenClaw MCP list, and we can see that no server has been configured. So now let's just register this MCP server. Again, all the comment will be posted on our LB Social website. All right, so now I believe that the server has been registered. So let's just check this list one more time. Great, so now you can see that our server has been successfully registered to the OpenClaw. Now let's go back to Telegram. So this is where we'll talk with our AI chatbot. So here I'm going to find out my main bot. And here, let's first tell the AI agent to use this server. So here we are telling the AI agent, so using this MCP server to find out the structure of our database and also available indexes. All right, so now we can see that our AI agent was able to return result. So here we have the structure of our node and also relationships. We also have this vector embedding index that is being successfully created, which means that now OpenClaw can use this MCP server. If we want the OpenClaw to, number one, understand our questions in a natural way, and also number two, to format the returned result so that we can create a customized skill to call this MCP server. So let's do it. Okay, so let's bring the skill creator. All right, so now we can see that the skill creator mode is being activated. So here we're going to create this skill. So basically, we want our AI agent to create a skill to use this MCP server and also tell you what tools are available. And also, I think the most important part is that how do you want to format the response? Okay, so let's send out this prompt to create that skill. All right, so now you can see that this skill has been created. And also if I check my skills, you can see here it has 2 skills actually. And the one that is available is this newly created, that is LB Social YouTube Graph Assistant skill. All right, so let's try this skill and also try to use our MCP server. I want to learn OpenClaw and also N8N. Can you recommend some videos? All right, and now we have this result. So first, deploy N8N on Google Cloud. And second, connect OpenClaw to N8N. And third, build this knowledge graph. And also for each step, they tell me the video title, where to watch, and also why this step matters. Let's try another question. So here I'm saying why use Docker to deploy N8N. All right, and it gave me the results. You can see that in the context LB social tutorials, so there are several benefits of using Docker to deploy this N8N. All right, so in this tutorials, we connected OpenClaw to our customer YouTube GraphRAG MCP server, and we first tested the MCP server locally, and then we registered it with our OpenClaw, and finally used Telegram to query the Neo4j knowledge graph. The key idea is simple. So MCP gave OpenClaw a standard way to call external tools. And in our case, the MCP server handles Gemini embeddings, Neo4j search, and retrieval from our LB social tutorial knowledge database. So now our OpenClaw can answer questions using our own video content, not just general model knowledge.